You're building an API. Your front end needs to prove who's calling it, and you're staring at three options: Basic Auth, bearer tokens, JWTs. Pick wrong, and you either over-engineer a weekend project or ship a security hole straight to production. Here's the good news. These three aren't competitors. They're a ladder. Each one exists to fix a specific problem with the one before it. Once you see that ladder, you'll never be confused about which one to use again. Today, how each method works, what it fixes, what it breaks, and the mistakes that turn authentication into a breach report. This is part 1 of an authentication series, the foundation everything else builds on. Let's climb. First, one distinction. Get this wrong and everything after it gets muddy. Authentication answers, who are you? Authorization answers, what are you allowed to do? Today is purely the first question. Now, why is who are you even hard? Because HTTP has no memory. Picture a drive-through window. You pull up, order, pay, drive off. The window closes. Next car pulls up, and the window has no idea you were ever there. No memory, no relationship. Clean slate, every single car. That's HTTP, and it's not a bug. Forgetting everything is exactly what keeps HTTP simple and fast. But it leaves you with a problem. You have to prove who you are on every single request. Every request. So the whole game of authentication is really one question. What do you say at the window every time you pull up? That question has 3 answers, and they're our ladder. Answer 1. Just say your password every time. That's Basic Auth. Answer 2. Say it once, get a wristband, show the wristband. That's bearer tokens. Answer 3. A wristband with your name already written on it. That's a JWT. Each rung fixes the one below it. Let's start at the bottom. The obvious first idea: repeat your password at the window, every request. Mechanically, it's this simple. Take your username and password, join them with a colon, encode that string in base 64, and send it in the authorization header on every request. One word in that sentence should bother you: encode. Base 64 is not encryption, it's encoding. Think of a gift wrapped in paper. It looks different from the outside, but anyone can tear the paper off in 2 seconds. There's no lock, there's no key. So why bother? Because HTTP headers only allow certain characters, and base 64 turns username:password into characters that are safe to send. That's the entire reason. Compatibility, not security. So problem number 1. Send Basic Auth over plain HTTP, and anyone watching the network reads your password directly. Over HTTPS, you're fine. TLS encrypts the whole request, headers included. Without it, you might as well tweet your password. But HTTPS doesn't fix problem number 2, and this is the one that kills Basic Auth. Your real password travels with every single request. Every request is another chance for it to land somewhere it shouldn't. A server log, a proxy log, a cache. Your actual password sitting in plain text in a log file. That's a breach waiting for a Tuesday. So, Basic Auth's verdict: fine for internal tools, local development, machine-to-machine calls on a network you control. Beyond that, we need the next rung, and the next rung starts with one idea: stop sending the password. Instead of repeating your password, do what a club does. Check ID once at the door, then put a wristband on you. From then on, nobody asks your name. They look at your wrist. That's a bearer token. But first, clear up the word bearer because it confuses everyone. Bearer isn't the token, it's the delivery instruction. Think of an envelope with bearer on the front. That word tells whoever handles it, this belongs to whoever is holding it. It says nothing about what's inside. Bearer is the envelope, the token is what's inside, and it can be almost any format. The simplest thing to put inside is an opaque token. Here's the flow. You send your credentials exactly once. The server checks them, generates a random string, that's your wristband, stores it next to your name in a database, and hands it back. From then on, every request shows the wristband, authorization bearer, and the token. The server looks it up in its list. You're in or you're not. Why opaque? Because the wristband is blank. It's a random string. It means nothing by itself. The only thing that knows who it belongs to is the server's list. So the server has to check that list on every single request. Look at what this rung fixed. Your password gets sent once, not thousands of times. Lose a token? The server deletes it from the list. Cut the wristband off. Done, without touching your password. Want it to expire overnight? Easy. And look at what it broke. That list lookup runs on every request. A database hit every time. And at scale, that's real money. Worse, run 5 API servers and all 5 need to see the same list. Now you need Redis or a shared database, a whole piece of infrastructure whose only job is remembering who's wearing which wristband. Which sets up the next rung perfectly. What if the wristband didn't need the list? What if your name was written on the wristband itself? That's a JSON Web Token, a JWT, a token that carries its own data. The server doesn't look you up, it reads the wristband. Decode 1, and you'll see 3 parts, separated by dots: header, payload, signature. The header says how the token is signed, an algorithm name like HS256, and that it's a JWT. Hold that thought, it matters in a minute. The payload is the writing on the wristband, facts about you, called claims, a user ID, a role, when the token was issued, when it expires. Some claim names are standard: sub for subject, exp for expiration, IAT for issued at, and you can add your own on top. Now the part that catches almost everyone. The payload is base64 URL encoded, and you already know what that means. Gift wrap, not encryption. Anyone holding the token can read everything in it. Paste any JWT into jwt.io, and the payload is right there in plain text. So the rule is simple. A JWT payload is a glass wristband. A user ID? Fine. A role? Fine. A password, a social security number, a credit card? Never. So if anyone can read it, what stops anyone from changing it? The third part, the signature. The server takes the header and the payload, runs them through a hash with a secret key, and that hash is the signature. Change one character of the payload and the signature no longer matches. Rejected on site. Think of it as a tamper-proof seal. You can see through the glass, but you can't touch what's inside. Tamper-proof and private are 2 different things. A JWT is only the first one. And here's the payoff, the reason JWTs took over. Verifying that seal is pure math. No list, no database. Any server, anywhere in your fleet, can check a JWT completely on its own. The shared token store from the last rung? Gone. But the latter rule holds. Every rung breaks something. Remember revocation, cutting off the wristband? With opaque tokens, delete the row, done. A JWT isn't in any list, nothing to delete. The server doesn't track it at all. So revoking a JWT early needs extra machinery. A blacklist, which quietly reinvents the list you were escaping. Or versioned claims checked against user state. Or the pattern almost everyone actually ships. Short-lived access tokens plus a refresh token. That pattern deserves 30 seconds because it's the real-world answer. The access token is a JWT that lives briefly, commonly around 15 minutes. Fast, stateless, verified by math. When it expires, the client trades a second credential, the refresh token, for a fresh one. And the refresh token does live in a database, which means it can be revoked. JWT speed with an emergency brake. And it's why expiration windows matter so much. They're the ceiling on how long a stolen token stays useful. One last piece, how that seal actually gets made. 2 options, 1 metaphor each. HS256 is symmetric. 1 secret key signs and verifies. A house key. The same key locks and unlocks the door. Perfect when one system controls the whole house. RS256 is asymmetric. A private key and a public key. A mailbox. Only the private key can put mail in, sign tokens. But anyone with the public key can check what's inside, verify them. The rule of thumb, 1 app, 1 backend. You control everything. HS256. Many services all verifying tokens from one central login service, RS-256, because you hand every service the public key, and the private key never leaves home. Everything above falls apart if you get these wrong. 5 mistakes, all avoidable. 1. Always HTTPS. Basic, bearer, JWT. None of them survive plain HTTP. TLS encrypts the whole request, headers included, no exceptions. 2. Where the token lives in the browser. 2 common homes, local storage or an HTTP-only cookie. Local storage is readable by any JavaScript on the page, so one injected script, one XSS hole, and the attacker walks off with the token. An HTTP-only cookie can't be touched by JavaScript at all. That door is closed. But cookies get sent automatically, which opens a different door, CSRF. The fix: HTTP-only cookies with same site set to strict or lax, both doors closed. 3. Expiration that fits the risk. Short access tokens, longer refresh tokens. A JWT valid for a year isn't convenient. It's a year-long window if it leaks. 4. Never write your own crypto. Use an audited library, JSON Web Token in Node, PyJWT in Python, the established one in your language. Those have survived real attacks. Yours hasn't. 5. Pin the algorithm. Remember, the JWT header says which algorithm to use? There's a classic attack built on exactly that. The attacker edits the header to say none, no signature needed, or downgrades RS-256 to HS-256, and a naive verifier obeys the attacker's instructions. Modern libraries mostly block this by default, but say it explicitly anyway. Whitelist the algorithms you accept. Never let the token choose how it gets verified. So, which rung is yours? The framework is one sentence. Climb only as high as your problem requires. Internal tool, your team, your network? Basic Auth over HTTPS is genuinely fine. First rung, nothing to over-engineer. A normal application, real users but not fighting for every millisecond? Opaque bearer tokens with server-side sessions. Easier to build, instant revocation, and honest truth. For most apps, that database lookup was never your bottleneck. Second rung, happily. Public-facing API scaling across many servers, or microservices verifying tokens from one login service. That's what JWTs are for. Stateless verification, nothing shared. Third rung. Don't reach for a JWT because it's trendy while a plain session would do. Match the complexity of your auth to the complexity of your actual problem. The latter, one more time. HTTP forgets you, so you prove yourself every request. Basic Auth repeats your password every time. Simple, but the password is everywhere. Bearer tokens fix that. Password once, wristband after, but now there's a list to check on every request. JWTs fix that. The wristband carries its own data, sealed by a signature, verified by math. But now revocation needs machinery, so short-lived tokens plus a revocable refresh token bring back the break. Every rung fixes the last one's flaw and buys a new one. Choosing well means knowing which flaw you can live with. Part 2 climbs higher. OAuth 2.0. What actually happens when you click Sign In with Google? Grant types, PKCE for mobile, OpenID Connect, and single sign-on. All of it stands on what you just learned. See you there.